Recording. This is the week 3 of the course. I believe everybody already used to their R environment. In this week, we're gonna talk about some probability set theory, and also we'll see some distribution of the data, and also do some little bit of practice in R environment. So let's begin. But before we start, is there anybody have any questions for me? That's all right, thank you. And I believe that the sound is okay today. Thanks. So let us begin. Just one sec, I'm sharing the screen. So here we go. Let's start. As I said, our agenda is just some probability and the set theory. We will see some distribution of the data and some sampling distribution. Also, we'll try to practice some distribution and the binomial distribution and the normal distribution in the R environment. Because this week is this week is not much more R and some sort of theory in this week, but I think in the next week there is no theory. Most of the things are gonna be in the R environment today. But this week's theory is mostly easy stuff, not so hard, just easy to go. So first of all, when we discuss about the probability and the set theory, there are a couple of things to remember in relation to the probability. That is, as said by Mr. Laplace, probability is a common sense which reduced to calculation, or I can say that scientific way to measuring the uncertainty. The probability theory is useful for understanding, studying, and analyze the complex and real world system. Also, probability is important for measuring the likelihood occurring in the statistical learning. So those who have done a little bit of advanced statistical learning, they knows what is called the likelihood, which we will use mostly in the various kinds of regression and classification problem. Mostly in the regression problem, in the like the linear regression and the logistic regression, this kind of thing. Okay, and probability always be within 0 and 1, not more than that. And it is a deep topic but very useful to apply in the straightforward way in the mathematical sense and statistical application. So when we talk about the probability, we will use some sort of term which is especially used for statistician and to handle or deal with the probabilistic term, like experiment, sample space, event, probability, rules of probability, and conditional probability. Although there are something like called the rules of probability, but I haven't seen in our materials it was covered by the rules of probability, but maybe there was a conditional probability. Anyway, we will go through sort of some of them so that you can understand what are they. Uh, First of all, the experiment and sample space. So whenever we want to see any outcome from any desired things, that is called the experiment. Like if you want to see the three car are racing in the racing field and you want to make predict which one gonna be first, second, or third, you can make some permutation and combination on that experiment, and this kind of permutation and combination can be cast as a term of a sample space. And another example in here, like tossing a coin. So whenever you toss a coin, which is a very common example which everybody would like to give and show, then possibilities either should be head or tail. So this is called the sample space, and the probability is because there are two only occasion gonna be happen, then the probability is 50-50. So this is how we termed as probability. Another example, suppose we can say, is there any raining today? So this is our experimental design. Then sample space can be rain or no rain, and then we can calculate. Suppose we know that rain gonna be last year rain gonna be 138 days in 365 days. So this is the probability of gonna be, is there any rain today, or and no rain is rest of them, or we can say 1 minus this term, which is called no rain. So this is just as an example to show what is what is the experiment, what is the sample space, and what is the how to calculate the simple probability from there. Another thing is, this term is very important, and in our lecture materials they cover this as well, which is called the Venn diagram. But I have seen a very useful link in YouTube. This link I have mentioned in here. They have very series of link relation to the set theory to high level of probability, and then there are various kinds of distribution of the data. So if anybody have time, then they can go and have a look this website. This is very useful, I have ever seen in space of probability. So if you guys go there and have a look, and they explain really so many things very nicely in a very broad sense, and they're very useful. So another term we use in the probabilistic way is called the event. Something called event. Event is nothing but a subset of sample space, sample. And these things came from this Venn. This is called the Venn diagram. Venn diagram. So suppose in here, left hand side, this circle, you have three items, 2, 4, and 6. That means A, 2, 4, and 6. That is the set of three numbers which you put in A. And in here, right hand side, there is another circle, another sort of data, and you have 4, 5, 6, 7, and 8, which is a set of B. So we termed it this way: A and B. That means when you say A and B, that mean A and B mean both some sort of data which you have in both of the A and B. So 4 and 6 is common in both A and B. That's how we denote it, like in this way. And A or B, that means something which is A already in A and also in B. We denote it like in this way. There are so many other explanation, and they go on very depth to explain the probability theory in this website. So if you guys go and have a look, then you will see much more example relation to this sort of space. So this is called the Venn diagram, right? An axiom of probability comes actually from the Venn diagram. In probabilistic way, we write it like this way: a probability of A or B, I mean in this term, except that this term, which comes like probability of A, probability plus probability of B, minus probability of A and B. And A and B, we denote in here probability of AB. Anyway, we will see in the next page, practical example. We denote probability of a negative A, that means something probabilistic which is not in this term, that means 1 minus this term. Something like we have seen in previous page in here, rain or no rain. So we can, if there were other term mean by this term 1 minus this term. So if you get one probability and there are only two occasions, then you can get the another one by only minusing the from -1, minus from the 1. So this is called that term. Suppose as an example, there is a probability of rain today is 0.4, and there is a probability of rain tomorrow is 0.4, and both of the day the probability is 0.1. So what is the probability it does not rain either of that day? So in this kind of problem, when we face in the real life, we can bring the solution using the probabilistic theory. So we know that from here, rain at least today or tomorrow from here. Today, if A is today, B is tomorrow, then probability of rain today or tomorrow mean from the other is here probability of A plus probability of B minus both of the day, which mean probability of A, probability of B, probability minus both of the day. This is the term. So which is 0.7. So this is 0.7 is the probability of rain at least today or tomorrow. So if we minus from 1 this term, which will be probability will not rain either of the day. So this is how we calculate the some real life this kind of scenario in the problem. Another important term in the space of probability is called the conditional probability. Conditional probability is very important in the real life and also in the statistical learning and the machine learning. We will always face this scenario and this kind of situation. Conditional probability mean to see a pro to say to calculate a probability based on another term. So suppose probability of A and B seems that B already happened. B term is already happened. So in that kind of situation, we come through this term to this term. Probability of A and B, A or A and B divided term which already happened. I mean probability of B already happened, which is gonna go by down there here. Suppose as an example, somebody got two tests and the probability of her passing both of the tests is 0.6 and the probability of her passing first test is 0.8. What is the probability of her passing the second test given that she passed the first test? So this realistic problem we have to see straight away the problem first. The problem is said that what is the probability of her passing in the second test given that she has passed in the first test, right? So we write down this in this way. So once if you get the problem probability of passing her second test, which you already know that she already passed in the first test. So the term which is already happened gonna go in this side so that it will be less confusing for us. And also this term gonna be in the down in here. So if we're gonna be confused, okay, in the top probability of second and first, because we go from that formula we can write down that, but what gonna be the down there? Down there it's gonna be the term which is already happened, already done. So that means probability of first and second, we know that in both of the term probability is 0.6 and the down there probability is already done. So the probability of her passing the first test is 0.8. So from here we can say that probability of her passing second test is given he already passed the first test is 0.75. So in the real life and in the scenario, we have to face the conditional probability a lot, and we can see this example. You can see this example. I showed the video link, and also in the website you will see so many examples of conditional probability. The main theme is to understand what is the conditional probability and how it to be calculated, right? So now, so this was the part of the probability and set theory. I came to a shortcut way because I have to cover some other things today as well. But the important thing is try to go through this web link and have a look. If you have time, then you will be get a very clear and good understanding about the depth of the probability from the beginning to end, even from the scratch. Those who don't have any understanding about the probability and set theory. Okay, so distribution, when we call the distribution of the data, and we have to remember two important things. One is called the one important thing which is called the knowing the characteristics of the variable of the random variable. So I realized that one of the most important issue on sampling the data is to know and understand what is the variable and what kind of variable we need to define the distribution of the data. So if we have a random data, and we can actually categorize that in two way. One is called the discrete random variable, and another one is called the continuous random variable. Discrete random variable, which is like to flip a coin. Flip a coin. Suppose if you flip a coin, or if you see say, something amount of win, or somebody is present or absent, this kind of characteristics of the data, and we can call that as a discrete random variable, because it is not a continuous as it is discrete way. On the other hand, the all sort of measurement like height, weight, I mean the normal trend of data which we got in our real life, and also in our various of data set which we use in practical life, we call that kind of data is continuous random data. So whenever we come to the distribution of the data, discrete random variables distribution is calculated from the distribution is comes to calculate the is called the binomial distribution, and the data comes from the way is called the Bernoulli trial, and the data collection is called the binomial distribution. On the other hand, the most famous kind of distribution is called the normal distribution, which we always try to figure it out, and which we always try to convert our data on that way, which is also called the bell-shaped distribution, or the Gaussian distribution. But various books term it as a various way, all the way same. Main theme is to uh, find the distribution of the data, and also is it if it is not a normal, and if it is not a normal, we try to convert our data, yeah, in a normal distribution way. We will also see an example of a practical example of in R how we find that our desired data set, or any column or any variable is normal or not. If it is not a normal, then how much is abnormality is in that data set, something like that. So to calculate the binomial distribution, this is a very good formula in statistics. This is the formula. So this term is actually NCR, which is written down in this way: factorial n by factorial x, n by n minus x. And this term is explained in here. There was another practical example I found in the web. So, and I will show this one as into the R environment as well. The problem was studies showed that color blindness affect 8% of the men. And suppose if you take the 10 random sample from the human, from the random people, what is the probability that two men are at least color blind? So this kind of calculation, we come to a solution to find out the binomial distribution. So from the mathematical point of view, this is the formula, and then you put all the terms from here to this formula, and finally this is the result. 0.148. At least two people are colorblind from your selected random sample. But this one I will show in the R is very easy to coding, and then just only one code of line in R to understand this kind of problem. So the thing is, whenever any kind of problem like this one we face, we have to just we have to see how it works, and maybe if possible once in a lifetime we can do it by hand manually. But once if we know how it works, then better to find the solution from Python or R. So this is the all about the binomial distribution. The next things to discuss about, anyway, we will go through that part in the distribution part in our session very shortly. Then another big things for us to discuss today is the normal distribution. I think already you guys know the some of the term already because of yesterday's lecture. This is the very important things in the statistics to understand and know. As soon as we know this one, then it will be very good for us to work with any sort of statistical data and statistical distribution. Um, Basically, normal distribution is a sort of smooth and well-shaped things to see, and the data is follow the smooth way. And in the middle position of zero, when we define it as zero position, in that position, median, mean, and mode should be in a equal way, which is present in the middle thing. And we define mu as a mean and sigma as a standard deviation. And uh, standard deviation mean how far the data is from the mean, from this position to that position. So most of the data as the curve said, that most of the data is lie in this region, but as soon as you go from far to the mean position, that means zero position, slowly the data density gonna be go down. So 100% or so, most of the data is in to and up to after the three standard deviation, there is no more data maybe. This is how we calculate, and this is the formula of statistical formula to calculate how the data is came to this way from this formula. This is a very big formula, but there is a very big explanation about this formula, and it will be found in the books how it came to this shape. And this is called the probability distribution function, and some people call it as a PDF. So we have to remember that, as I said in the previous page, if middle position is the zero position, or the mean position, mean position, then 68% of your data is lie in between this range. So which is called the one standard deviation of the data, and two standard deviation is like 95% of the data is reaching in between this yellow and green range. However, after three standard deviation, and there should be maybe very few, or maybe almost ignorable data to calculate it or to be considered. So this is the distribution of the normal distribution, and it is called the rules of thumb for the normal distribution. So basically, this thing is to remember, and whenever we work on the statistical learning and do various kind of testing in future. ANOVA testing, we will face the Z distribution, we will face the T distribution, and 2OA ANOVA testing. Various kind of statistical testing we will face in future when we work with our real data. Then we will remember this figure, and then this figure and this figure. And so we have to keep this figure in our brain when we work with another kind of distribution, to bring that distribution in this distribution. Because once if you have this distribution, you can put various kinds of statistical experiment to make a decision at the end of the day. But if you don't have the data, which don't have, but the thing is, in the real life, you won't face any sort of data which really follows this kind of shape. That's why the challenge for the statistician and the data scientist and the data engineer is to find out the way how to bring your data set in this kind of shape, or how to work with this kind of shape, suppose, or how to or so that you can come to a decision. On the other hand, in advanced statistical learning, there are some other technique they're gonna use to bring the data into this kind of shape, which is called the normal density estimation, density function, kernel density estimation, and called the smoothing function. That is another part of the study. But the thing is, all the way their aim also to bring the data in the normal distribution, so that they can make some sort of statistical experiment to bring the data in this shape and to make a decision. Okay. This one is called the standard normal distribution. So this is a very special kind of normal distribution when this position is zero. Because this position is zero, this is one distribution, one standard deviation. Then it is called the standard normal distribution, right? So in our previous phase, in this figure, we said this is mu. Mu may be any sort of number, but in here, if we say that mu is equal to 0, if mu's value is 0, then we can say this is a standard normal distribution. Not only normal distribution, but also standard normal distribution. As I said before, we will calculate the Z distribution whenever we have the data in a normal distribution. Z distribution comes from this formula. Z distribution mean to find a position of the data which is how far from this middle position. So if you have a data in this point or in this point or in here or in there, then with this formula you can calculate how far that point is to the mean, and this is the formula to calculate the Z. But we need the Z distribution and study to find the comparison between two set of data, or the data uh, which comes from two separate kind of distribution. So if you have a data, if you have two data set, then you can find the Z figure and you can compare the Z figure to come to a decision. Anyway, this will be much more interesting if you guys can see in a example of the Z distribution in the maybe in the next week. So in theory, you will in theoretically, if you don't really understand how it works, but in practical, whenever you get the data set and you need to work the Z value of two data point, then you will understand that it is very interesting to get the Z point and from the data set. Another sort of distribution we need to remember is called the T distribution. T distribution is very easy. This is nothing but the Z distribution, but in T distribution, the data set is very limited, and the researchers are seeing that if the data set is less than 30 or around 30, then I mean the data number is around below 30, then you can have to go through the T distribution. So whenever you do your experiment or your assignment, and you see that you have done some sort of you have done some survey and you have the data point which is 25 or 26 data point you are starting with, then you can go through the T distribution analysis, and there are various kinds of tools you can go through to come to the decision from your data set. But if you have, suppose if you have 70, if you have 27 data set and you are using the Z distribution or some other kinds of distribution, maybe you will get a biased result. That's why the T distribution is also important whenever the data set is less than 30. Anyway, we will jump into the RStudio now to show that our how to calculate a data set, how to find the distribution of a data set, and how to calculate the binomial distribution I showed in this figure, in this problem. So let's go to RStudio. So this is RStudio. Remember we said that there was a sample size was 10, and yeah, we have to find out if from the 10 sample data set, what was the probability that at least 2 of them gonna be color blind. That was our study to find. So in our environment, we calculate it like this way: DBINOM, simple. And then first thing is you have to find 2 people are they color blind at least, and sample size you find is 10, at least 10 from 10 of them, and you said that at least 8% of people was color blind. So probability gonna be 0.8. That's simple, that's it. So see the result is size 10. Oh sorry, should be actually 0.08 because 8%. See, so this is the result. So once if you find this kind of, so this is actually realistic though. And what about if I say that what is the possibility that at least 10 people of the So at least 10 people color blind from 10. So let's see how what R is giving us. dbi the binomial of, we say that only 10 of them is color blind from size of 10. How it is possible? I mean, what is the possibility of that to be happen? Probability of 0.08, right? It really mostly very small number. See, after point there are 11 zero, then 1.1. So this is a realistic result that can be happen. And what about the probability that at least one person gonna be color blind? Let's see, what would be just one person. So this result should be bigger than one result should be little bit of bigger than two. Yeah, see, so you see, just a little bit because it is much more possibility that at least one person gonna be color blind from the 10%, whereas 2% gonna be color blind. It should be little bit less of probability. So in here, so this is also we can using our common sense. We know that that should be happen. Finding two people is much more difficult than finding just one people. So whenever we want to find this solution in R, we have to go through this way, and it is very simple and easy. Our next agenda was to find the distribution from a created data set. Is everything okay? Okay. Yeah, that was scientific notation. Yeah. So let's go to find out the normal distribution. In R, we can define the mean and standard deviation and to find the some normal distribution, which is a function is called R normal distribution. N normal NOR M distribution equal to R norm if data point is n, and suppose there are 1000 data point, and so we can define the mean. The mean is 30, and also we can define the standard deviation. Standard deviation is 3. So this is how this is our this is our one dimensional vector, one dimensional array, 1000 data point in here. So let's see what is the histogram, how it looks like. Histogram of normal. This is a histogram of this normal data set. We have our created data set. This is looks very good, good shape of the distribution. But as I said, this is not very easy in the real life to get the data set which looks like this way. So how it looks like, let us find out from a R built-in data set, but to see how yeah, any variable find out or to find any variables shape, how it is the shape of the data set. Is it the normal distribution or how far it is from the normal distribution. So we know that there are so many building data set in R, and we can get the data set. I said in the last week, if you write down data like that and run this line, then you can see this is the building data set. You can work with this data set anytime in R to practice anything in your come to your mind. So get it like this way, right? So one of the data set in that list is called the tooth growth. All right. So let's get that data set. How to get it? Data is we can get it various ways. So the best way is to do this way. See? So once if you run this code, then it will toolbox not found. See, yeah. I don't know why it give me this. things, but it already been there. Anyway, let's work on that data set. Since it is a very big name, I like to do I like to do under D. Yeah. Oh, W missing. Oh, sorry. Yes. Okay. 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 But see, R is so small there, so R is so smart that see, although I made a mistake, it thinks that this is what it. I mean, I already, but although there is a mistake, but it brings the data set in here because R is so smart that it thinks this was my intention, right? Interesting. Okay. See, this is a big data set. So what I normally do is I bring the DF like this way. So okay, now it is better for me to work with because I get the data set of that one, which I can call DF. And now let's see the head of the data set. Head, head of the data set is DF, control enter. Only three variables, len and these two. So let's say we work with only this line, right? This is a numerical value. To see the structure of the data set, we write down str, structure of the data frame, right? So then once if you run this code, you can see that uh, variable names and their types. So the first one is numerical, other one is factor, another one is called numerical as well. So let's see what is the distribution of numerical len. I mean first one, this one. So to do that, let's see do the histogram first because histogram the first way to find out any investigation. Right? Is histogram of DF len. Right? So this is the histogram of that data now from that variable. Seems like it is not a normal distribution because most of the data seems like in that this position concentrated in the this position, but we can't really make any decision at this point that we can say that okay, my I have seen my this histogram in this something like that, so I can't make it. So it is not a normal distribution. You can't really do one simple experiment in statistics to say to come to a decision. So let us go through some other experiment or some other kind of work. As we know that we can check this one from the week one. We have seen that we can do it by QQ plot. So let's see how the QQ plot looks like in that variable. So how to do that? QQ and so QQ norm data frame of the data frame, this one, right? Okay, this is the QQ plot. Looks not bad, but from this position, when you see the histogram, you said that we decided that it is seems like not a normal distribution. But once you see this line, you can see seems like it is a normal distribution. That means you are changing your decision little bit at least because of seeing this experiment. So so let's plot one line. If you line, if you line of PF. Okay. So see at this position, the whole point of showing this example or our example or examining this example that we once if you have a data set and you want to examine one variable where how is the distribution look like, you can only no, you can't only go through the histogram to see how it looks like, and that's why there are various kinds of statistical learning we apply statistical tools we apply to make any any solid decision, because once if you make any decision based on any only single one or two kinds of experiment, then maybe it will be biased, or maybe you can't give a proper decision. So from histogram you said that it is not a normal distribution, seems like. After that, whenever you get the data, when you get the data QQ plot, you said that it is seems like little bit of normal distribution. But once you get the line, QQ line, which is a 45-degree angle of the data point, it seems like most of the data point on the lies on the line, but little bit of them is little seems like an outlier of the data point. It seems like this point, maybe this point, or maybe this one is an outlier. So still you have an opportunity to check the outlier using the box plot of that one, right? So let's see the box plot. If you see the box plot, maybe if there is an outlier, you can define that. So actually no outlier. So the box plot is saying that there is no outlier of that data point. Now the final part of the study we're gonna go through is to make one. There is another test in statistical test and statistical learning, that is called the Shapiro test. So in that you will go through details. I will go through details on the called the H0. I mean the uh, null hypothesis, and then to accepting or rejecting the null hypothesis. So at this point, if I say that I believe that I guess the distribution is a normal distribution. So I say this is my null hypothesis is a normal distribution, and I can find out what the Shapiro test said is called. Okay, yeah. Or yeah, so it's Shapiro test, and then inside of them there's nothing but that's the data point, the variable name. At this point, it said that as I said, my null hypothesis was it is a normal distribution, and then the p-value is greater than 0.05. So if any p-value is greater than 0.05, then we can say that we can't reject the null hypothesis. So that means the I can take a final decision that my distribution of that line of data or that variable of the data is a normal distribution. So my whole point of showing this example is that it is very easy to come to a decision whether your any data set or any data point is normally distributed or not. But once if you have a data set, what our normal tendency is, we see a histogram to see the distribution of the data, but we can't really to make a further and solid decision, you can't really see the histogram and make a decision. You can go through further investigation, something like to see the QQ form, the QQ plot, and then to see the line plot, and then you can't still make a decision in here. You can see that there are maybe some outlier inside the data, but still to check that one again further, you can go to the box plot, and then you say no, there is no outlier, and then again you do further investigation and another one testing statistical test, and you finally say that since the p-value of my that test in the data point in that that it should be a normal distribution, then I can say that at this point of view it is a normal distribution. So this is one kind of way to checking your variable from your data set and make a decision whether your data distribution, whether your data is a normally distributed or it is not it is not it is abnormal distribution. So luckily this data set is a normal distribution, normally distributed. But the question is, when you see a data set which is not a normal distribution and normally, then maybe you can go through further investigation to make it as a normal distribution. Okay. Actually, look, it depends. It depends on personal. It depends on personal preference. I'm talking to Karan because it really depends on you. Whether you want to go through so many some this kind of a distribution of or experiment or not. I'm showing just maybe this is the possible way to go through or to do some investigation for your data set, whether it is a normal distribution or not. Okay, but statistics is such statistics and probability is such kind of uncertainty is that it depends on your personal preference and your what you gonna come to a decision. Because suppose you are a statistician and another statistician, and there is a data set I given and you said this is not a normal distribution, but somebody else said this is a normal distribution. So you have to show your evidence, and he will show his evidence, and he will prove that this is a normal distribution. That's why as much as possible to investigate, it is better for you to make a solid decision. Okay. Yeah. So yeah, that is what it is. Because you see a distribution which is not a normal distribution, but at the end of the day, I prove that this is a normal distribution, and that is the proof. And you go through two or three type of investigation. That's why there are thousands type of investigation, and most of them was implemented in R language as well. So since you have the R language, it is very nowadays. I mean, suppose 20 years ago or 15 years ago, people was struggling to go through this kind of investigation because there was no tools. But nowadays, since you have the tools, why not you go through that things to make a solid decision, right? And Jason, you was asking about it is in the R studio. Yeah, it is in the R studio. Got not promise. You have a look. Hang on. Let me see again. Data should be here. Truth Broad, I have seen that one. I see the TOOTH, this line, right? This is the data and the investigation of the data. I mean the description of the set. This is the data set. Okay, this is in there. Also, Nairu, it is the best idea for you to investigate your data set, not all of them, maybe some of them, which is your targeted data point, which is your targeted variable. Suppose whenever we was working on the Jason, you want to say something?
Hi, Jilani.
Yeah.
So my question is that let's say that I have about 5 variables, out of which is one is a nominal, and then other is an ordinal, and then some is a discrete, and then some is a continuous.
Yeah.
If I take so test on the continuous variable,
Yeah.
and if my results show that it is a normal distribution, does that mean that my discrete variable will also follow a normal distributions? So, or do I have to keep testing for that, and then also for my categorical variables also to test again?
I think the best idea is to test your targeted variable. I mean, if there is a data set and you targeted data point and your targeted variables are two or three, so it is a best idea to see the distribution. Yeah, you have to, because once if you see one variable mean the column name, I mean the attribute name.
Yes, so, yes, I meant by the column name only. Yeah.
So that one, if that one is a normal distribution, you can't say that other one is also. No. You have to go them individually. You have to go them one after another.
Oh, thanks a lot, Jilani. That's what was actually thrown a confusion in my head. Is that you see my understanding all this time I was following. If one of the column follows the normal distribution, the other variables will also have to be. This is what the thumb rule in my head. So you clarified that, and thanks a lot for that.
Thank you. Yeah. So yeah, David, what you said, the data set is in R. Yeah, that data set is in R to grow, and there are not only them. So many data set is already in R, which is called the CAR data set, Titanic data set, for us to study, for us to check and investigate something. Yeah, all the time. So you can get get any data set from build in our data set, and you can work on that and do some investigation by yourself. Yeah. Yeah, box plot is the best way. Yeah, current box plot is the best way to find the outlier of the data set, and also if you can make a uh, if you can make a scatter plot by seeing the variable and by seeing the position of the data set, you can imagine that that data point is a outlier. Also, once before going to box plot, go to the scatter plot, and then uh, uh, then you can make sure that two things, if two of the investigations suggest same thing, then you can say that there is an outlier. And especially in the statistical learning, outlier detecting the outlier is very important, because sometimes if you go further statistical analysis, like it is nowadays in the machine learning and statistical learning, there are so many uh, things like something called the linear regression or logistic regression. This kind of study, you need to avoid the outlier. Once, if you can't avoid the outlier, if you make a model including your noise or the outlier, noise is, in my point of view, one sort of outlier. So that is that not give you the proper result. Yeah. How to print the R script? I was not able to do it on computer. I have to convert it before printing, convert to PDF. That's what it is. I had to. That's what you have to do in our scripting. Remember, in the first lecture, I told that our Markdown is the best way to work with. If you have an idea to work with R Markdown, then it is a very good way to do that. But at this moment, since you have to work with R Markdown, R scripting, then this is the way. Last year, I remember somebody was doing their project in R Markdown, and there are so many things to you can do with R Markdown, and yeah. So if somebody is very expert in R already, and they know how to use R Markdown rather than R scripting, then I think the best way is to go to R Markdown. And I was asking Glenn personally this question: whether students able to use R Markdown or not. Then he said that if you know already R Markdown, then you can use it, no problem. Because using in R Markdown, you can submit your coding easily without doing anything. Just clicking a button, then it will convert your code into a R file, into a PDF file, uh, or if you are novice, then I think this is the best way you are doing. Just convert it into PDF and submit it like this way. Because at this moment, best way is to learn something, how the coding is working. And but if you are in an advanced stage, little bit of advanced stage, then you can go through the R Markdown. Okay. So this is the facility given by our our programming environment. Okay. No. It not gonna affect on your marking. Never, never. Yeah. So those for those who already know R, I know some people in here. They know R very well, and they know R Markdown also very well. So they can work in the R Markdown. Isn't it? Yeah, that is also the way to do it, Sunny. You are absolutely right. So okay, Nehru, I think you will be okay. You will be all right. Once if you have the our coding, then you can manipulate it, or if you have any further question, you can ask in the discussion board. You will get the answer from so many experts. Okay. Yeah. So anyway, guys, so this is until now the today's session, and we will come back in the next week with some more statistical learning and some more statistical experiment, which will be very useful, because I believe next week is most important week in the point, because in the next week we're gonna go through some more t-testing, also Z distribution. We will go through 2OA t-testing, maybe some sort of ANOVA testing, this sort of testing to see and manipulate and getting the data set and make a decision from the data set. So next week is very important week, and in the next week there will be no theoretical slide. So we're gonna see only on our scripting in the next week. And today's slide and little bit of R coding I will upload in the Ultra, and you guys can see and have a look and download it. Okay. Okay, Jason should know that there are so many of them data set in the R now. So yeah, work on them, practice on them, and enjoy. Thank you. Until the next week. Have a good week, guys. See you then. Bye bye.